So okay, you can see here TCP. Under TCP we have HTTPS, HTTP, FTP, SSH, Telnet, SMTP, POP3, IMAP protocol available. HTTP is nothing but hypertext transfer protocol, which is having a port number of 80. HTTPS, hypertext transfer protocol, secure, 443 the port number. Okay, FTP, file transfer protocol, port number 2021. SSH, port number 22. Telnet, port number 23. SMTP, port number 25. POP3 110. IMAP 143. So these are the port protocol available. Okay, this all comes under TCP protocol. Okay. So if you want, you can take a screenshot also. Okay. So we'll continue. Okay.
Done, sir.
Under UDP protocol, user datagram protocol. User datagram, we have DHCP, DNS, NTP, SNMP, TFTP. DHCP, Dynamic Host Configuration Protocol. DNS, Domain Name System or Domain Name Server. NTP protocol, Network Time Protocol. SNMP, Simple Network Management Protocol. TFTP, Trivial File Transfer Protocol. Okay, this all comes under UDP protocol. So what is the port number? DHCP 6768, DNS 53, NTP 123, SNMP 161 and 162, TFTP 69. So this is the protocol which comes under UDP. Under IP, under IP we have multiple protocols available. Okay, but main protocol we can say ping and trace route. Ping and trace route. Ping, okay, mainly for checking the connectivity, whether I have connection or not. To connection, if I want to check the connectivity, I can use ping command. If we go for trace command here, trace command is nothing but tracing the path from source to destination. Okay. The difference is nothing but, so you can see here, I can go to my command prompt here. Command prompt, I want to check the connectivity from my laptop to Google server. So ping google.com. Ping google.com here. If I type ping google.com, okay, if I get reply from particular IP address, okay, I'm getting reply, right, along with the full connection, right? That means what? Okay, 4 packet has been sent, 4 packet has been received here. So okay, I'm checking the connectivity from my laptop to Google server. It says succeed. Okay, so I want to give a trace command here. Trace RT google.com. Trace RT google.com here. When you give this command, it traces the path. It traces the path from my source to destination. Tracing the path from my laptop. What is the next hop address? Okay, might be my next hop will be my router available there in my office. Okay, that is my next hop address. From my laptop, my packet has been forwarded to the router. From the router, it has been forwarded to next hop. Next hop is nothing but the router which is available there in the ISP. Similarly, we have multiple routers are available there in the internet. It crosses multiple routers and reaches the Google server. You can see here. It shows the IP address of the routers and the devices which is available there in the internet. So this is nothing but 190.160.101 is nothing but the IP address of my router which is available there in the home office.
Okay.
Similarly, next 111 might be this is the IP address of the ISP.
ISP.
Okay. Similarly, we have multiple IP address available. It shows. Suppose if I get something like a store, something like that, might be there is a firewall available or there is a device which they are not able to reveal the IP address. Okay.
Okay.
Okay. So finally reaches the Google server page. You can see the IP address of Google server here. 142.250.205.238. 142.250.205.238. Okay, this is the IP address of the Google server. So it goes from my laptop and finally reaches the Google server with multiple hops here. Okay, so the difference between the ping command and trace command is nothing but ping command has been used for checking the connectivity, whether I am having connection with the server or not, whether I am having connectivity or not. That's the ping command. But trace command is nothing but it traces the path from source to destination. That's called trace command is all about. Clear?
Okay.
So networking types. Next topic is nothing but networking types here. Okay, when I say networking types here, we have different types of network available. Okay, we have different types of network available. So network has been classified based on the design. Okay, network has been classified based on the design, or we can say architecture. Based on the architecture, we are classifying the network. Network has been classified based on the topology. Classified based on the topology. Similarly, network has been classified based on the size, or we can say area. Network has been classified based on the connection, whether it's a wire or wireless. Network has been classified based on the protocol, either proprietary protocol or standard protocol. Okay, so we have different types of network based on the different terms here. Okay, so we'll go with one by one. First, we are going to discuss about, okay, network has been classified based on the area. So when I say based on the area here, what are things available here? We can say LAN and WAN. Network has been classified based on the area here, or we can say size of the network. LAN and WAN. When I say LAN here, local area network. Network in a small geographic location is called as LAN. Network in a small geographic location is called as LAN. Example, your college computer lab, or you can say office network site, is all comes under LAN connection. Network in a small geographical location is called as LAN. When I say WAN here, network in a large geographical location is called a WAN. Network in a large geographical location. Example, internet. Internet is an example for WAN connection. Okay, so based on the size, we are classified into LAN and WAN. Here, this LAN and WAN again have multiple networks are available here. MAN, PAN, SAN, HAN, WAN, VPN. So, a lot of networks are available. We will go with one by one. Okay. So here, after that, we are going to discuss about, okay, network has been classified based on the connection, wired connection and wireless connection. Apart from that, we are going to discuss about network has been classified based on the design or network architecture, that is nothing but peer-to-peer and client server. So we are going to discuss one by one. Okay. So we already discussed about LAN and WAN here. So LAN is nothing but local area network. Network in a small geographical location is called a LAN. Okay. So for example here, you can see here network in a small geographical location is called a LAN here. This is called a LAN, local area network. Okay, LAN is a local area network, a small geographical location. Example, you can say your computer lab, school or office building. This source comes under LAN here. Okay, so network in a large geographical location is called a WAN. Large geographical location is called a WAN here. Wide area network. Okay, example I can say, okay, within the country, within the city, within the continent, source comes under WAN connection. Network in a large geographical location is called a WAN here. So example you can say here. So Chennai, this location is Chennai here. This location is nothing but Philippines here. India, Philippines location. They are connected. This is called connected via WAN here, cloud. So again classified into, okay, MAN, metropolitan area network. What is metropolitan network? Okay, metropolitan, we are going to discuss. MAN, campus area network. PAN, personal area network. SAN, storage area network. HAN, home area network. BAN, body area network. VPN, virtual private network. Metropolitan area network. What is a metropolitan area network? Network within the city. Okay. For example, here we have an office. Okay, might be I can say they have Amazon office. Okay, one office in Chennai location. Okay, so I think we can say branch office one and branch office two, another location within the Chennai. So two office available there in the Chennai. Like you can say here, office. Okay, both offices are available in the same city. Okay, if you want to connect two offices in the same city, is called as what? MAN here. Same city is called as MAN. If you want to connect two offices in the same city, is called as MAN. Then we'll discuss about PAN here, personal area network. So what is a personal area network? If you want to communicate, I want to do some communication between my devices. For example, my mobile phone, my printer, my laptop. I want to transfer my information from my mobile phone to my laptop. Is called as PAN here. Okay, personal area network. I want to move all the photos from my mobile phone into my laptop. This comes under PAN here, personal area network. So connecting all the devices. Here you can say here mobile phone, printer, camera, or I'm connecting everything. This is called a PAN here, personal area network. HAN, home area network. What am I home area network? Home area network is within the home here. I have a lot of device available. Might be I can say my mobile phone, smartphone here. I'm having smartphone here, laptop, desktop, computer we are having, printer, smart TV, smart refrigerator, smart appliance. We have a lot of appliances available. Okay, if you want to communicate all the devices with each other, this comes under what? HAN here, home area network. So within the home, we are connecting, multiple appliances, multiple devices. This comes under home here, home area network. Okay. Campus area network. What is the campus area network? Campus. When I say campus, you can imagine the college or university. Okay, in a college or university, we have multiple departments are available. Okay, we have multiple departments available. Each department will have some computer labs. Okay, they are having some computer labs are available, right? In each department, the departments have been located in the same building or the multiple buildings, different buildings. Like I can say the example here. You can see here the different buildings are available here. So, in a university, we have library available. Okay, commerce, arts, science, lot of labs are available in each department. Okay, so if they want to communicate, if you want to communicate all the departments, all the lands within the campus, is called as what? Campus area network.
Okay.
Okay, then SAN, storage area network. What is storage area network? For example, in company and all, we have, if you want to do some project, in your laptop, you are not going to save the project in your laptop itself, right? Where you are going to save the information? You are going to save the information in a separate location called storage server. Yes or no? We have to save the separate location called storage server. We are not going to save the we are not going to save the project in the laptop itself. We are going to save in a separate location called storage server. Okay, here in the storage area network here, we have we have to connect all the devices in terms of optical fiber cable. Optical switches are available. So it provides high speed network. It provides high speed network here. Okay. So whatever information, whatever project you are doing in your laptop, you are going to save the information in the storage server here. In the storage server, storage area network, we have lot of storage devices are available. Apart from that, they are connected via optical fiber cable and optical switches are available. It provides a high speed network. That's all called as storage area network. Okay, BAN,
Okay.
body area network. Body area network. What is a body area network? The body, if you want to monitor, if you want to monitor the heartbeat, BP, insulin level, if you want to monitor, I can insert the sensors to monitor the heartbeat, to monitor the BP, to monitor the insulin level. I can monitor. Like I can example, I can say like a smartwatch. This is one of the example for body area network. It will monitor the heartbeat, right? It will monitor the heartbeat. It monitor, it sense everything. This comes under
Okay.
body area network. Finally, VPN here, virtual private network. Virtual private network. VPN is nothing but virtual private network. Private networks are connecting via public internet is called as VPN. Simple definition. Private networks are connecting via public internet is called as VPN. For example, okay, we have office, okay, one office. You can see here, we have HCL office in one location, another office in another location. Might be this office in India, okay, this office in UK. If we want to connect this office together, I cannot lay a cable, right? It's not possible to lay a cable to connect the two offices together, right? I cannot put a lease line connection to connect the two offices together, right? So what we can do? We can go for VPN connection. So we will have internet. Okay, you have separate ISP with you. He is also having separate ISP. Okay, what you are going to do? You are going to connect this office via. You are going to connect this office via tunnel here. They are going to create a tunnel here, separate tunnel. Okay, separate tunnel here. So even though it's a public network, here, whatever data you are forwarding here via this way, all the data getting encrypted before forwarding via this channel. Even though the information has been publicly available, okay, they cannot be able to retrieve the information. Okay, able to retrieve the information. All the data which has been forwarding via the channel is nothing but in the form of encrypted format from one location to another location. Highly secure. This highly secure. This type of connection is called as VPN, virtual private network. There are two types of VPN available. Okay, one VPN is nothing but side to side VPN. Another VPN is but okay, remote access VPN. Side to side VPN is nothing but okay, you are going to connect one office in one location to another office in another location. It's called a side to side VPN. Remote access VPN is nothing but, for example, like right now most of them are working from home, right? So like remotely we are working, right? So if they want to connect your network, your laptop to the company network, your laptop is company network, this kind of connection is called as remote access VPN. Okay. So you can see here one location, okay, another location here. Might be you can assume here this is the client here, this server here, okay, but you are going to connect via public network only. That's internet only you are going to connect. But how we can connect via internet here? We have to create a channel. Okay, this is nothing but a channel here. We have to create a channel here. The channel only we are going to make a communication from client to server. But this channel is highly secure. It's a channel, or you can say tunnel, is highly secure. Whatever the data we are forwarding has been encrypted before moving to the tunnel here. Okay, again in the final destination it has been decrypted and the server. Okay, and the data has been forwarded to server here. So this is what VPN is all about here. Like when it comes to the real connection, how it look like? Okay, this is the setup for a network. Normally we have office, in office we have LAN connection. Multiple pieces are connected here. From the PC it's connected to switch here. From the switch it's connected to router.
Router.
Okay, again they will have modem. So we have a setup. This is nothing but your office. Example, I can say Hyderabad office here. I want to connect to Chennai office. What I can do? I have to contact the ISP. They will provide the connection for me. So from my home, from my office, they will provide the internet connection to, okay, internet connection, right? So they are connecting my office to that, okay, ISP. So ISP they will have modem. Again they will have router. They will have a router. Then connected to multiplexer. This is not even multiplexer. So in the multiplexer, we can say here, we have one office, right? Similarly, we have multiple offices in the Chennai location or Hyderabad location, right? All the offices are connected, Hyderabad location, all these offices are connected to the multiplexer only. From the multiplexer, we have separate channel, fiber optic cable has been forwarded from your office to the Chennai office. Similarly, Chennai office also, same setup. Okay, we have LAN available. From the LAN, it's connected to switch here, switch to router, router to modem here. Okay, from the modem it's connected to another modem which is available there in the ISP. Again connected to router, then we have multiplexer. So this is a complete setup for end-to-end connectivity about the network.
Okay.
So first clear, right? Any doubts?
No.
So topology. Network has been classified based on the topology. Network has been classified based on the topology. Okay. So we have multiple topologies available, but we should understand about what is topology is all about. Topology is nothing but structure of a network, or we can say arrangement of a network is called a topology. Structure of a network, or we can say arrangement of network, or we can say different way of connection is called a topology. Topology is nothing but structure of network, or we can say arrangement of network, or we can say different way of connectivity is called a topology here. Here, this topology has been classified into two types: physical topology and as well as logical topology. Physical topology is nothing but it defines how the devices are connected with each other is called a physical topology. How the devices are connected with each other is called a physical topology. Logical topology is nothing but how the devices are communicating with each other. This comes under logical topology. Okay, how the devices are connected with each other is called a physical topology. How the devices are communicating with each other is called as logical topology. So we can see here multiple topology available: bus topology, star topology, ring topology, mesh topology. Similarly, we have other topology available: hybrid topology, tree topology, multiple topologies available. We are going to discuss one by one. Okay. First, we can go with bus topology here. In bus topology, we have a cable. Okay, we have a cable available. In the cable, we have multiple devices are connected here. Multiple devices are connected here. The cable I'm saying, right, is nothing but a coaxial cable. Coaxial cable here. So it acts as a backbone. Okay, backbone coaxial cable, single backbone cable here. Okay, in the backbone cable, all the devices are connected here. Okay, the backbone cable, both end has been terminated. Okay, we have terminated available. They are connected via T connector here. This is to be T connector. T connector here.
What
Terminated. Okay, end. This
oh,
end, right? Both ends are said to be termination here. Okay, this is nothing but T connected. But right now,
okay.
we are not using this topology. Currently, we are not using this topology. So, any reason for it? Why we are not using this topology?
The setup is too long. It takes
Hmm?
much time.
If there is any problem happen here, okay, in one end of the connection, there is any problem happen in the backbone cable here. Any problem happen? There is a cable cut or something like that. Any problem here? What will happen? I'll get the internet connection only in one area only. Okay, I'll get the interconnection only in one area only. I cannot get the interconnection. Okay, this kind of type of connection is called as what? Bus topology. So currently we are not using this bus topology. Currently we are not using this bus topology here. So all the computers are connected to a single cable called as bus here. Transmission of data from any computer travel across the length of the cable. Okay, the bus here, and the travel via another computer also. We are not using this topology currently. Okay, the reason is nothing but okay, if there is any problem happen in the backbone cable, so one end of the device cannot get the internet connection at all. Next topology, ring topology. The ring topology, how it connected here? One host is connected to next host here. Another host is connected to another host. Another host is connected to another host here. It forming a ring. It forming a ring here. This setup is called as what? Ring topology. This connection also currently we are not using. Okay, this setup also currently we are not using. So the reason here why we are not using, okay, why we are using the ring topology here? If we have any problem, if any one of the device having some issue, okay, what will happen? The data will not be forwarded from one end to another end here. Okay, so the data will not be forwarded. Okay, because of this, currently we are not using this ring topology. Okay, we are not using this ring topology. In ring topology, what happened here? Each computer is connected to each computer is connected to two other computers, forming a closed ring-like structure here. The data is transmitted in one direction only. Okay, what is the drawback here? Okay, if any one of the computer break down here, the entire ring will get disabled. Okay, right? Because of this, we are not using this ring topology. Star topology.
Oh, this all is about how computers are connected not how they are communicate.
How computers are connected, different way of
No,
connecting.
is it physical topology or
Physical
logical
topology, physically
Okay.
connected, physically connected. So here we discuss about topology, right? So
Mm-hmm.
topology, structure of network, how the devices are connected with each other. That's what we are discussing here. So in this case, we are discussing multiple topology. But currently, we are checking which topology currently we are using.
Okay.
Okay. So this topology, star topology is available, right? Star topology. In star topology connects all cables to the central point of concentration. So we have central switches available, right? All the devices are connected to the central switch here. All the devices are connected to central switch here. It's called as what? Star topology. In star topology, all computers are connected to the central device called switch gear. The data to be exchanged between any two computers passes through the switch gear. Suppose, for example, if you want to transfer the data from one device to another device, the information will be passing via switch only. Okay, information will be passing via switch only. So, because of that, currently we are using this topology only. So almost all the network in our college, in our office, wherever you are going, if you want to create a LAN connection, we are using this kind of topology only. You can see the diagram here. All the client machines, you can see all the client machines here. Okay, multiple PC we are having. Okay, all the PC has been connected to switch here. Printer also connected here. Server connected here. Modem connected. All the devices are connected to a switch here. This kind of topology is called as what? Star topology.
Star.
So currently we are using this topology only. So in office and all, we can see how they are connected actually. Okay, like if you are having a laptop, or if you are having a desktop and all, okay, you have laptop or desktop here. Okay, we can see the cable, right? Okay, we can see the cable. This cable has been connected to a network interface card in your PC. The cable has been connected to the IO port available there in the disk. IO port available there in the disk here. IO port available there in the disk. Okay. So after that, from this IO port, okay, it has been sent to the device called switch here, which is available inside the rack. Similarly, we can have multiple PC. All the PC has been connected to the same switch only. All the PC has been connected to the same switch here. Okay. So this kind of setup is called as what? This kind of setup is called as star topology.
Star.
Okay.
Star topology.
So currently we are using star topology. What about mesh topology? In internet, you can see lot of routers are connected with each other, right? They are all connected with each other. Okay. This setup is called as what? Mesh topology. So each computer network device are interconnected with each other. Okay, interconnected. So each computer is connected to each other computer network, forming a full mesh topology. Okay, it's called a mesh topology. You can see here all the devices are connected here. This is called as what? Full mesh topology. Partial, that means what? Only few devices
Few.
connected with each other. It's called as what? Partial mesh topology. Full mesh and partial. Extended star topology. Extended star topology. What do you mean extended star topology? You can see here. We have multiple switches are available. Okay, multiple switches are available, and multiple switch, each switch will have what? Multiple pieces are connected here. This is called as what? Extended star topology. So we are using currently we are using main topology here. One is mesh topology currently we are using. Another is what? Star topology we are using right now. Mesh topology and star topology we are using. Next thing, network has been classified based on the architecture. Network has been classified based on the architecture here. So there are two types of architecture available. One is nothing but peer-to-peer and client-server architecture. Peer-to-peer client-server architecture. So you can see here in peer-to-peer architecture, all computers are connected with each other. Okay, connected with each other here, but there is no control. No one can control. Each device having this resource. Okay, each device we are having, right? All the devices having their own resource. Okay, they can transfer the file from one device to another device. They can retrieve the file here. There is no control from anyone. Okay, they can have their own username password. Okay, they can log in, they can have their own username password. Okay, there is no control here. Any one device can communicate with any other device. But when it comes to client server technology here, client server technology, server will server will control all the client machine here. If client want to transfer the information from one device to another device here, server will decide whether it can transfer or not. If we have the permission, then only we can transfer information from one device to another device. Even if you want to change the IP address of the client also, we require a server admin username password. Without server knowledge, we cannot do anything here. If I want to install any kind of software also, if you want to install any kind of software also, without server knowledge, we cannot do anything. Okay, that's what we can say client and server here. Okay, this is client server. This comes under what? Okay, network has been classified based on the architecture or based on the design here. Architecture design. Network has been classified based on the connection. There are two types of connection available here: wire connection and wireless. So wire connection nothing but we are connecting the device using a cables. If you can use a cable called coaxial cable or two-stepper cable or optical fiber cable, whatever may be. If you use a cable for connection, okay, if you use a cable for connection, that is called so wire network. Wireless nothing but you are connecting the device, okay, wirelessly. That means what? Might be via Bluetooth, might be via infrared, or might be via radio frequency. We are connecting the device with each other. This comes under wireless connection. Next thing, network has been classified. Okay, we are going to discuss about different types of communication. What are the different types of communication available? Simplex, half duplex, and full duplex. We have different types of communication available. Simplex, half duplex, and full duplex. What is simplex here? Simplex is nothing but one-way communication is called a simplex. One-way communication. Example, TV broadcasting, FM broadcasting, all comes under simplex here. Half duplex nothing but two-way communication, but one at a time. Two-way communication, one at a time. Example, walkie-talkie. That is an example, walkie-talkie. Full duplex. Okay, two-way communication, both at a time. Two-way communication, both at a time. Example, mobile phones.
Mobile phones.
So simplex, half duplex, full duplex. Here you can see simplex communication, mainframe. Data has been forwarded from mainframe to monitor here. Simplex communication. Sorry, this was simplex communication, right? It's correct. Half duplex, two-way communication. Two workstations available. So both has been forwarded, but only one at a time.
One.
Full duplex, two-way communication, both at a time.
Both at a time.
Again, we have different way of communication. Different way of communication. Unicast, multicast, and broadcast. Unicast, multicast, and broadcast. Unicast. Okay, what do you mean unicast here? Okay, unicast is nothing but one-to-one communication is called as unicast. Unicast is nothing but one-to-one communication is called as unicast here. Multicast, one-to-many, but not all. That is called a multicast. Broadcast, one-to-all. That is called a broadcast. Unicast, one-to-one. Multicast, one-to-many. Broadcast, one-to-all. For example, in a college environment, okay, you are discussing some secret only with your friend, I think. You are passing some information only to your friend. This is called as unicast. When you say multicast here, might be team. Okay, might be volleyball team, football team, dance team, anything. You are passing information to a group, to a team. It's called as multicast. Broadcast means what? One to all. Okay, whole college. You are passing the information to the whole college. It's called as broadcast here. Okay, here you can see unicast means what? One to one. Multicast, one to many, but not all. Broadcast, one to all here.
All.
So clear? Yes. So far what we discussed in today's topic. See, this started with protocol here, right? We started with the protocol. So protocol has been classified into IP, TCP, UDP, and ICP. IP is nothing but Internet Protocol. TCP, Transmission Control Protocol. UDP, User Datagram Protocol. ICP, Internet Control Message Protocol. Under TCP, okay, we have three protocols. Under TCP, we have multiple protocols available.
Multiple.
What are the multiple protocols here? HTTP, HTTPS,
HTTP,
FTP, Telnet, SSH, SMTP, POP3, and
POP3.
IMAP.
Okay.
So we should know the port number also. Okay. So we told you, okay, like totally we have port numbers. Okay, starting from 1 to 69,535 port numbers are available, right? You can see the port number here. Starting from 1 to 65,000. 1 to 65,535 port numbers are available, or 0 to 65,535 port numbers are available. Okay, 535 port numbers are available. Okay, 65,535 port numbers are available. It's not easy to remember all the port number here. So we have some well-defined port numbers are available. You can see here some of the port number. 20 FTP, 21 FTP. This is for data. This is for control. 22 SSH, 23 Telnet, 25 SMTP.
Yes.
So we should remember all this kind of port number. So I told you here you can see this port number here. This is enough. As point of view, this is enough right now. FTP 2021, SSH 22, Telnet 23, SMTP 25, DNS 53, DHCP 6768. Okay, TFTP 69. TFTP 69 port number. Okay, SMTP 25, POP3 110, IMAP 143, okay, TFTP 69. Yes, SNMP 161,
161, 162.
So these are the port numbers. Okay. Then we discussed about UDP protocol here, DHCP, DNS, NTP, SNMP, TFTP. So ping and traceroute command we discussed, right? Ping command. Ping command has been used for checking the connectivity. Okay, whether you have connection or not. Trace command has been used for tracing the path from source to destination. Trace command has been used for tracing the path. Okay, with an example I told you here, ping google.com, whether I am having connection or not. Ping command is it. Trace command will trace the path from source to destination. Okay, tracing the path from source to destination. That's what trace command is all about. Tracing the path from source to destination. Trace command. So then we discussed about, okay, a type of network, right? So type of network has been classified based on different terms here. It has been classified based on the, okay, area, classified based on the topology, classified based on the standard, classified based on the design, and classified based on the connection. Okay, so we discuss all the things. Okay, what are the different types of network available here? Classified based on the size, they have been classified into LAN and WAN. LAN is nothing but local area network. WAN is nothing but wide network. Network in a small geographical location is called a LAN. Network in a large geographical location is called a WAN. Again, this has been classified into MAN, CAN, PAN, SAN, HAN, BAN, VPN, everything. What is my HAN? We can say we discuss. What is my MAN? We discuss. MAN is nothing but metropolitan area network. Network within the city. If you want to connect two office within the city is called as MAN. PAN is a personal area network. Network, okay, network personally. Okay, for example, I can say I want to transfer the information from my mobile phone to my laptop. I want to move the file or photos from my mobile phone to the laptop. This comes under PAN here. Personal devices. Communication between the personal devices. SAN, storage area network. If you are doing any kind of project in your laptop, you are not going to save the project in your laptop itself. You are going to save it in a separate location called storage area network. Okay, in a storage network. Storage network consists of what? Storage servers available. They are all connected by a high-speed cable, like optical fiber they are using for connection. Optical switches are using, they are using in the storage area. Provide high speed. That's called a storage network. Campus network. In a campus, we have multiple departments available. For example, if I go for engineering college, we have EC department, CSA department, IT department, AAA department, mechanical department, civil department. All the departments having them computer labs. computer lab. All the labs are connected with each other. It's called as what? CAN. CAN is nothing but home area network. Network within the home. Might be you are having a mobile phone, laptop, desktop, smart TV, smart refrigerator, smart fan. Okay, we are connecting all the appliances. This all comes under hand, home area network. WAN, body area network. So in the body, if you want to monitor the heartbeat, BP level, say insulin level, they can insert the chip sensor. Okay, to monitor the heartbeat level, BP level, insulin level, everything can be monitored. So smartwatch is one of the example for the band, body area network. Finally, we can say VPN, virtual private network. Private networks are connecting via public internet is called a VPN. When I say private network here, one office in Chennai location, another office in Delhi location. I want to connect from one office to another. We cannot lay a cable from one office to another office, right? We are connecting to internet. That particular office, Delhi office, also connected to internet. By internet, we establish a VPN connection. If so, all the data which has been forwarded from one end to another end as in the form of encrypted format. This comes under VPN.
VP.
So type of connection based on wire or wireless. What is the difference between wire and wireless connection? If you are connecting via cable, it may be optical fiber cable or coaxial cable or two-stepper cable. If you're connecting the device via cable, it's called a wire network. Wireless network, you are not connecting via wire. It may be Bluetooth, it may be radio frequency, infrared. You are connecting the device with each other. This comes under what? Wireless network. Network has been classified based on the design. There are two types of design available: peer-to-peer and client server. In client server, client will design who can able to transfer the information. Client will control all the server will control all the clients. Server will control all the clients. If client want to transfer the information, okay, it has to get permission from the server only. Server need to provide permission for the client. If you only permission is having, this client is having the permission, then will they can able to transfer the information. Okay, this comes under what? Client server. But peer-to-peer, there is no control. They can have their username, password. They can have their own resource also. They can transfer the information one device to another device at any time. But when you say client server here, the username password, if you type the username password is getting authenticated in the server. If you provide the correct username password only, you can able to log in. Otherwise, you cannot able to log in. Okay, so all comes under. Okay, this comes under network has been classified based on the design. Okay, we discuss all the things. Then finally we discuss about topology also.
Topology.
Discuss, right? So network has been classified based on the topology. Okay, what is the topology available? Okay, we have multiple topology available: physical topology and logical topology. Physical topology is how the devices are connected with each other. They are physical topology. Logical topology is nothing but how the devices are communicating with each other. Comes under logical topology. Okay, again classified into bus topology, star topology, ring topology, mesh topology. Currently, we are using star topology as well as mesh topology. Okay, so all your devices are connected here. Central device. This comes under star topology here. Okay, this comes under star topology. This is the topology currently we are using. Okay, we are using all the devices are connected to the centralized device called star topology. Simply mesh topology is nothing but all the devices connected with each other. Might be, I can say, the internet. We have multiple routers are available. They are called connected with each other. Okay, there are two types available. So that's nothing but full mesh topology and partial. Full mesh means what? All the devices are connected with all other devices. Partial means that only few devices are connected with each other. Partial mesh topology. Then we discussed about type of communication and way of communication. Type of communication, three types are available, right? Simplex, half duplex, full duplex. What is simplex communication? One-way communication. Example: FM transmission, TV transmission, radio broadcasting. Half duplex, two-way communication, but one at a time. Example: walkie-talkie. Okay, in walkie-talkie you can say, right? Okay, if you want to talk, actually you have to press the button, then you have to talk and release the button by saying over. Then only other person can able to talk. Okay, two-way communication, but one at a time. But when it comes to full duplex, two-way communication, both at a time. In the mobile phone, we can say anyone can talk at any time, right? That comes at a full duplex here. Then we can say unicast, multicast, and broadcast. That comes under way of communication. Unicast nothing but one-to-one communication. Only one device to another device. It's called unicast communication. Multicast, one to many, but not all. Even though multiple devices are available, I am forwarding only to group of devices only. That's comes as multicast. broadcast nothing but one to all broadcast. Unicast, multicast, broadcast. Clear. Thank you.